Let us now take the second model from this topic of equations, where we are going to learn about quadratic equations. Let us first understand what is meant by a quadratic equation. Now, in a quadratic equation, all the powers of the variable are positive integers and the highest power is 2. So it is nothing but a second degree polynomial which is equated to 0. That means, as we have seen in case of a linear equation, the highest power of the variable was always 1. And in a quadratic equation, the highest power of the variable is equal to 2. And all the remaining powers are positive integers. The most general form of a quadratic equation is ax squared plus bx plus c equals to 0, where a is not equal to 0 and a, b, c are real. So this is the most general representation of a quadratic equation, that is ax squared plus bx plus c equals to 0, where x is the variable and a, b, c are constants. So as you can see here, the highest power of x is 2, the other powers are 1 and the third power here is 0. So as we can see here, the highest power of x in this form is 2. So such an equation where the highest power of x is equal to 2 or the highest power of the variable is equal to 2 is referred as quadratic equation. And a, b, c here are real constants. Remember friends, a cannot be equal to 0 in the general form of a quadratic equation. Why? Because if a is equal to 0, then this whole term will become 0. And the left out part is bx plus c equals to 0. And bx plus c cannot be a quadratic equation. Why? Because when it is bx plus c equals to 0, the highest power of x is only 1. And hence it becomes a linear equation. So for an equation to be a quadratic equation, the coefficient of x square should not be equal to 0. The other two coefficients can be 0, but a should never be equal to 0. Now, in case of a linear equation, we have seen that there is only one value of the variable or only one value of the unknown which satisfies the given equation. Why? Because the highest power of x in a linear equation is 1. But since the highest power of x in a quadratic equation is 2, there will always be two values of the variable which satisfies the given equation. That means in this equation we will have two different values for x which satisfies the given equation. And these two values are called the roots of the equation. There are two different methods to find out the two roots of the quadratic equation. The first method here is using the standard formula and the second method is factorization. Now as per the standard formula, the two roots of the equation or the two values which satisfies the given equation will be equal to minus b plus or minus root over b squared minus 4ac by 2a. Where a, b, c are the constants from the given quadratic equation. So we can see that the first value will be minus b plus root over b square minus 4ac by 2a, and the second value will be minus b minus root over b square minus 4ac by 2a. The other method to solve a quadratic equation is factorization. In this method, we factorize the given quadratic equation in terms of two simple linear equations. For example, the equation ax squared plus bx plus c equals to 0 can always be converted in terms of x minus alpha into x minus beta equals to 0. And once we obtain this form of the equation, we can say that alpha and beta are the two roots for the given quadratic equation. So friends, we can apply any of these two methods to solve the given quadratic equation and obtain the two roots. But remember friends, factorization of the given quadratic equation may sometimes become a complicated task. So in such cases, we can use the standard formula and obtain the answers in a straightforward manner. Let us now take an example and understand how to solve the given quadratic equation in both the different methods. As we have learned, the general form of a quadratic equation is ax squared plus bx plus c equals to 0. For example, x squared minus 5x plus 6 equal to 0 is in form of a quadratic equation, as the highest power of x here is equal to 2 and the coefficient of x squared, that is a, is not equal to 0. Now by comparison with the general form, we can understand that a is equal to 1, b is equal to minus 5 and c is equal to 6. And as we have already learned, there will be two different values of x which satisfies the given quadratic equation. So let us understand how to find out those two values of x or the two roots of this equation. As we have discussed earlier, the standard formula to get the values of x will be minus b plus or minus root over b squared minus 4ac by 2a. So let us now substitute the values of a, b and c in the given formula to get the two roots of the equation. So we can say that x will be equal to minus b, As in our case, we have seen that A is equal to 1, B is equal to -5 and C is equal to 6. So minus B would be minus of -5 plus or minus root over B squared, that is nothing but -5 squared minus 4AC, so 4 into 1 into 6 divided by 2A, that is nothing but 2 into 1. So this comes out to be 5, because minus of -5 is 5, plus or minus root over -5 squared is 25 minus 4 into 1 into 6 is 24 divided by 2 into 1 is equal to 2. So this will again be equal to 5 plus or minus root over 25 minus 24 is root 1, which is equal to 1. So 5 plus or minus 1 by 2. So the first value of x will be 5 plus 1 by 2 and the second value will be 5 minus 1 by 2. So we can say that x will be equal to 5 plus 1 by 2 or 5 minus 1 by 2. So 5 plus 1 by 2 is 6 by 2, that is equal to 3. Or the second value 5 minus 1 by 2 is 4 by 2, which is equal to 2. So the two values of x which satisfies the above quadratic equations are 3 and 2. That means the two roots for the given equations are 3 and 2. So this is how we can solve a quadratic equation with the help of the given formula, that is x equals to minus b plus or minus root over b squared minus 4ac by 2a. Now the other way of solving the quadratic equation, as I have already mentioned, is to factorize the given equation. So let us understand how can we factorize this equation and obtain the two roots. The given equation here is x squared minus 5x plus 6 equals to 0. Now in case of factorization, we will try to split this equation in terms of two linear equations. That is nothing but in the format of x minus alpha into x minus beta equals to 0, where alpha and beta will be the two roots for the given equation. To do that, we have to take the constant b and write it in terms of b1 plus b2 in such a way that b1 into b2 should be equal to a into c. So the most important part of factorizing the quadratic equation is this step. That is, we have to take the coefficient b and try to write it as b1 plus b2. That is nothing but sum of two numbers in such a way that the product of b1 and b2 should be equal to the product of the coefficients a and c. Now in the given equation, the value of a is equal to 1 and b is equal to 6. So we can say that a into c will be equal to 1 into 6, that is 6. So our job now is to break the number b as b1 plus b2 such that b1 into b2 should be equal to 6. Now b in the given case is minus 5. Now this minus 5 here can be taken as minus 2 minus 3. Why? Because minus 2 minus 3 is minus 5 and minus 2 into minus 3. If we try to compare with this part, b1 is equal to minus 2 and b2 is equal to minus 3. So minus 2 into minus 3, that is b1 into b2 is equal to plus 6. Minus 2 into minus 3 is plus 6. So this is the correct way of breaking the number b as b1 plus b2. Now keeping this in mind, the quadratic equation now can be written as x squared minus 5x can be taken as minus 2x minus 3x. So minus 2x minus 3x plus 6 equals to 0. Now we can take common part out of the first two terms. The common part here is x. So if we take x common, we get x minus 2. Similarly, from the third and the fourth term, if we take minus 3 common, we get x minus 2 equals to 0. Now again, by taking this term x minus 2 common, we have x minus 3. This should be equal to 0. So as you can see here, the quadratic equation x squared minus 5x plus 6 equal to 0 has been reduced in the form of x minus 2 into x minus 3 is equal to 0, which is in comparison with x minus alpha into x minus beta equals to 0. So the two roots for the equation here should be equal to 2 and 3, but because the roots for this equation are alpha and beta. So we can say that the two roots are 2 and 3. So x should be equal to 2 or it should be equal to 3. The reason for these two values to be the roots is because now when we say that x minus 2 into x minus 3 equals to 0, this is in the form of product of two numbers. Let's say this is m and this is n. m into n is equal to 0. We know that product of two numbers can be 0 only if either m is 0 or n is equal to 0. So if m is 0, that is if x minus 2 equals to 0, we get x equals to 2. or if n is equal to 0, that is x minus 3 is equal to 0, we get x equals to 3. So these are the two roots for the given equation, that is x should be 2 or it should be 3. So if you try to observe, the same values were obtained by the standard formula, that was x equals to 3 or 2, and even by factorization we have got the same answer, that is 2 or 3. So this is how we can either use the standard formula or the method of factorization to obtain the two roots of the given equation. Remember friends, the most important part in factorization is this step, that is b1 should be taken as b1 plus b2 such that b1 into b2 is equal to a into c. Once this is obtained, solving the remaining part of the question would be very easy. Let us now take the example 1 from model 2, which is based on the solution of quadratic equations. The question here is, solve the given equations and establish the relationship between the two variables x and y. So like we have done in case of linear equations, we first need to solve the two given equations, find out the roots of these two equations, that is nothing but the values of x and the two values of y, and compare them and establish the relationship between x and y. Now as we have discussed earlier, quadratic equations can be solved in two different methods. Either use the standard formula, that is minus b plus or minus root over b squared minus 4ac by 2a, or we can go for the factorization method. So let us try to solve these two equations with the help of any one of the methods and compare the roots to establish the relationship between x and y. Friends, as we know that using the standard formula is a simple and straightforward procedure, you can use that method to solve these quadratic equations at any point of time. But let us now go for the factorization method and understand how to solve these equations. Now the first equation here is x squared minus 10x plus 21 is equal to 0. So as we know that, first of all we need to find out the product of a and c, that is nothing but 1 into 21. 21 in this case. Why? Because a is equal to 1 and c is equal to 21. Now the value of b here is equal to minus 10. So we should try to split minus 10 in terms of two numbers in such a way that the product of those two numbers should be equal to 21. Now if we try to understand, minus 10 can be taken as minus 7 minus 3. Why? Because minus 7 minus 3 is minus 10 and minus 7 into minus 3 will be equal to plus 21. So this is the proper way of splitting the term b, that is equal to minus 10. Remember friends, minus 10 can also be taken as minus 8 minus 2. Why? Because minus 8 minus 2 is equal to minus 10. But the problem is minus 8 into minus 2 is plus 16. Whereas the product that we need is 21. So we should only go for that way of splitting the number b, which gives you the product as a into c. Now keeping minus 7 minus 3 in mind, let us try to expand this equation. That is x squared minus 10x can be taken as minus 7x minus 3x plus 21 is equal to 0. So by taking x common from the first two parts, we get x minus 7, and by taking 3 common from the next two parts, we again get x minus 7 common. Now if we take x minus 7 outside, we get into x minus 3 is equal to 0. So very clearly the two roots for this equation have to be x equals to 3 or 7. Since this is in the form of x minus alpha into x minus beta equals to 0. So alpha and beta are the two roots. So this is how we can solve the equation with the help of factorization method. If you are not comfortable with the factorization method, you can always use the standard formula to get the two roots. Let us now solve this equation with the help of factorization. Now here a into c is equal to 1 into 63, that is equal to 63, and b is equal to minus 16. So we should try to break minus 16 such that the product of those two terms should be equal to 63. Now as you can see here, with the help of trial and error method, we have to understand which particular way of taking minus 16 will give the product as 63. For example, if we try to take minus 16 as minus 10 minus 6, the product of two terms, that is minus 10 into minus 6 is plus 60, whereas we need 63. So minus 10 minus 6 is ruled out. So likewise we need to check with various cases and understand which particular case will give the product as 63. Now that particular case here would be minus 9 minus 7. Why? Because minus 9 into minus 7 is plus 63. So now the equation can be taken as y squared minus 9y minus 7y plus 63 is equal to 0. One important point which I would like to mention here is whether you take minus 9y first or minus 7y first doesn't make a difference. Why? Because at the end of the solution we finally get the same two roots for the given equation. So whether we take minus 9y minus 7y or minus 7y minus 9y, the answer will not be affected. Now taking y common here, we get y minus 9, and by taking minus 7 common, we again get y minus 9 equals to 0. So this can be taken as y minus 9 into y minus 7 is equal to 0. So the two roots of y here are 9 or 7. So now the two roots for the second equation are 7 or 9, and the two roots for the first equation are 3 or 7. And as given in the question, we are supposed to establish the relationship between the two variables x and y. Now if you try to understand, we have two values for x and two values for y. So we need to compare both the values of x with both the values of y and come out with the proper relationship between x and y. So as you can see here, the two values of x, x1 and x2 have to be compared with the two values of y, y1 and y2. That means we'll have four comparisons. x1 should be compared with y1, x1 should be compared with y2, x2 should be compared with y1, and x2 should be compared with y2. After all these four comparisons, we can establish the relationship between x and y. Now as given there, x1 equals to 3 and x2 equals to 7, and y1 is equal to 9 and y2 is equal to 7. So let us compare the values here and find out what is the relationship. Now if we compare x1 with y1, we find that x1 is less than y1. If we compare x1 with y2, x1 equals to 3 and y2 equals to 7. Again we get x1 as less than y2. Now let us compare x2 with the two values of y. So if we compare x2 with y1, that is 7 with 9, we find that x2 again is less than y1. And if we compare x2 and y2, we find that x2 is 7 and y2 is also 7. That means x2 is equal to y2. So these are the four comparisons between the two values of x and two values of y. So if we try to combine all of them, we can say that x is less than or equal to y. So the answer for this question should be x less than or equal to y. Why? Because in three cases we find that x is less, and in one cases x is equal. So by combination we can say x should either be less or should be equal to y. Similarly, if we get greater than in some cases and equal to in some other cases, then we can say that the relationship is x greater than or equal to y. If everything is less than, then the simple answer will be x less than y. If all are greater than symbols, then the answer can be taken as x greater than y. But in some cases, we find that some of the comparisons say x less than y and some other comparisons say x greater than y. And we can understand that x cannot be greater and smaller at the same time. So in those cases, the answer should be taken as relationship cannot be established between x and y. So in all the cases where we get less than and greater than at the same time, by comparing the two variables, the answer has to be taken as relationship cannot be established. And in the remaining cases, we can get the answer as either x less than or equal to y, or x greater than or equal to y, or x less than y, or x greater than y. Let us now take the second example from Model 2, which is based on the solution of quadratic equations. Now again, as we can see here, we have to solve the given equations and establish the relationship between the two variables x and y. So the first equation here is in terms of x and the second equation is in terms of y. The first equation is 17x squared plus 48x equals to 9. And the second equation is 13y squared equals to 32y minus 12. Now since the highest power of x here is equal to 2 and highest power of y in this equation is equal to 2, we can understand that both the equations are quadratic equations. So let us first get them in the proper form, that is ax squared plus bx plus c equals to 0. So this equation can be taken as 17x squared plus 48x minus 9 equals to 0. And this equation here can be taken as 13y squared minus 32y plus 12 equals to 0. By taking 32y minus 12 on the other side, the sign changes. So that is the reason we get minus 32y plus 12 equals to 0. Similarly here, by taking 9 on the other side, we get minus 9 equals to 0. So now these two equations are in the correct form, that is ax squared plus bx plus c equals to 0. Now we know that the equations here can be solved in two different ways, either by the standard formula or by the method of factorization. So standard formula can be applied very easily as it is a simple and straightforward procedure. But here let us go by the method of factorization and see how to obtain the roots for the given equations. Now the first equation here, a into c will be equal to 17 into minus 9, that is equals to minus 153. and b is equal to 48. So we now have to break up 48 as b1 plus b2 such that b1 and b2 product should be equal to minus 153. Now 48 can be taken in infinitely many ways. For example, 48 can be taken as 50 minus 2, it can be taken as 40 plus 8, it can be taken as 45 plus 3 and so on. But we have to take up the one in which the product of b1 and b2 is equal to a into c, that is minus 153 in this case. And that one will be equal to 51 minus 3. Why? Because 51 minus 3 is 48 and 51 into minus 3 is minus 153. So this is the correct way of breaking the number b in terms of two different numbers. Now using this, the equation becomes 17x squared plus 51x minus 3x minus 9 equals to 0. So if we take 17x common, we get x plus 3. And if we take minus 3 common here, we get again x plus 3 equals to 0. So the final equation is 17x minus 3 into x plus 3 equals to 0. Now as we have discussed earlier, for this product to become 0, either 17x minus 3 should be 0 or x plus 3 should be equal to 0. So if 17x minus 3 is equal to 0, we can say that x equals to 3 by 17. And if x plus 3 equals to 0, we can say that x equals to minus 3. So these are the two roots for the equation 17x squared plus 48x equals to 9. Let us now solve the second equation in terms of y. Here we find that a into c equals to 13 into 12, which is equal to 156. So we need to break up b, that is minus 32, such that we get the product as 156. Now the way to do that is minus 26 minus 6. Remember friends, you will have infinitely many ways of breaking minus 32, but we are going by only that one which gives the product as 156. And the way to do it is simply go by trial and error. There is no direct method in which we can understand how to split this. That can happen only with regular practice. So practice well on this step so that solving the equation by factorization becomes easy for us. Now using minus 26 minus 6, we find that minus 26 into minus 6 is plus 156. So by using this, let us now try to write the given equation as 13y squared minus 26y minus 6y plus 12 equals to 0. Now by taking 13y common, we get y minus 2, and by taking minus 6 common, we get y minus 2 equals to 0. So again 13y minus 6 into y minus 2 equals to 0. So y should either be equal to 6 by 13 if this part is 0, or it should be equal to 2 if the second part is 0. So the two roots of this equation are 6 by 13 and 2. Now the next part here is to compare the two roots and establish the relationship between x and y. As you can see here, the two values of x are 3 by 17 and minus 3, and the two values of y are 6 by 13 and 2. Let us now compare the two values of x, that is 3 by 17 and minus 3, with the two values of y, that is 6 by 13 and 2. If we take x equals to minus 3, then definitely x will be less than both the values of y. Why? Because both the values of y are positive, they are more than 0, and x here is less than 0. So obviously in these two comparisons, x will be less than y. Similarly, if we take x equals to 3 by 17 and compare with 2, again we get that x is less than y. Why? Because 3 by 17 will be less than 1. It is a fraction, and here this is 2, which is more than 1. So obviously x will be less than y when x is taken as 3 by 17 and y is taken as 2. Now the only comparison left out is 3 by 17 with 6 by 13. That is, if x equals to 3 by 17 and y is equal to 6 by 13, which of these two will be greater? And as we have discussed in the previous model, that to compare fractions, the simplest way is cross multiplication. So when we cross multiply, we get 3 into 13 on this side and 6 into 17 on the other side. 3 into 13 is 39 and 6 into 17 is 102. We know that 39 is less than 102. So obviously x has to be less than y. Why? Because whatever comparison we get here, same has to be taken for x and y. So now we can understand that in all the four comparisons, we find that x is less than y. When we take x as minus 3, then it is less than both the values of y. So x less than y and x less than y. Similarly, 3 by 17 and 2, we find that x is less than y. And in the fourth comparison as well, we find that x is less than y. Since in all the cases we find x is less than y, we can say that the answer here is x less than y. So this is the answer for the given question. So friends, this is how always we need to solve the two equations, obtain the two roots for each of the equations and compare them to establish the relationship between the two variables. Before we close the session, one important point which I would like to mention here is regarding the way in which the number B has to be split. As I've already mentioned, generally we have to go for trial and error method to find out what is the correct way of splitting the number B. But one point which we can understand here is, if we try to observe, 48 was taken as 51 minus 3. And here minus 32, the correct way to split is minus 26 and minus 6. Now instead of randomly checking with different cases, what we can understand here is, if you observe 17 and 51 bear a relationship between each other. That is, 51 is a multiple of 17. 51 is 17 into 3. Likewise, 3 and 9 also have some relationship between each other. 3 is a factor of 9. Why? Because 9 divided by 3 is exactly equal to 3. Similarly, even in this case, when we have taken minus 26 and minus 6, we can understand that 26 here again is a multiple and 6 is a factor of 12. So one point which is very clear is, the value B should be split in such a way that the two terms that we get should be multiples or factors of A and C. So instead of randomly checking 48 with 50, 45, 40 and so on, we can directly check with all the multiples of 17. That is 34 plus 14 or 51 minus 3. Why? Because 17, 34, 51, all these are multiples of 17. And out of these three cases, whichever satisfies the product has to be taken as the correct one. Similarly, in the case of minus 32, instead of randomly taking it as minus 30 minus 2 or 34 minus 2 or 35 minus 3, what we can do is observe the number A and take only these multiples of A to split the number B. For example, multiples of 13 are 13, 26, 39 and so on. So we'll try to take 32 in such a way that either it is 13 plus something or 26 plus something or 39 plus something and so on. And out of these 3-4 cases, whichever satisfies the product A into C, that can be taken as the correct one. So one very clear point that we need to understand here is, instead of going for random trial and error, we should only take the multiples or factors of the terms A and C. And hence the solution for this equation by factorization method becomes a little simple. Remember friends, if factorization becomes difficult in any of the equations, we can directly go for the usage of the standard formula. So depending on your convenience, you can either go by the standard formula or the method of factorization to solve the equations. That's all from this topic of equations. See you in the next session. Thank you.